We are already discussed asymptotic notation, right? Big O, omega, theta definitions and all. Before going to the problems, right? Before going to the problems on asymptotic notation, right? Let's see one more point which is pending. That is complexity classes. See this one, complexity classes. This is the thing which is pending. Let me complete this also. Afterwards, in previous years, whatever questions are there on the asymptotic notation, we will see now. Right? So let me complete this one. Complexity classes. This may be time complexity, this may be space complexity. These are complexity classes. Constant complexity, logarithmic complexity, linear complexity, quadratic complexity, cubic complexity, exponential complexity, polynomial complexity. Like that, almost like 7 things I written. Constant, logarithmic, linear, quadratic, cubic, polynomial and exponential, right? Like that 7 classes are there. Maybe more, but major things I written, right? Some people are asking, sir, what is the meaning of constant complexity? See this one. Constant complexity normally we used to write big O of 1. Constant complexity normally we will write big O of 1. 5 also constant, 10 also constant, 20 also. Instead of writing big O of 5, for all constant they kept one name, big O of 1. Big O of 1 means constant complexity, right? Please be careful. Next one, logarithmic complexity. What is that one? Big O of log n. That is the meaning of logarithmic complexity. What is the meaning of linear? Big O of n. What is the meaning of quadratic? Big O of n square. What is the meaning of cubic? Big O of n cube. Next one, what is the meaning of polynomial? Big O of. What is the meaning of polynomial? Big O of n power c, where c is constant. Where c is constant and c greater than 0. Polynomial, big O of n power c, where c is constant and c greater than 0. Right, that is the polynomial. What is the polynomial definition? Big O of, right, big O, polynomial definition is going to be n power c, where c is a constant greater than 0. Next one, what is the exponential? This is the exponential, big O of c power n, where c is constant, and c greater than, c is a constant, c greater than, right, c greater than 1. C greater than 1, where c is constant greater than 1, that is called exponential. So can you give some examples of exponential? What is the answer? 2 power n, 3 power n, 4 power n, right, something like that. Right, they are going to be, right, exponential. What is the meaning of polynomial? Can you give some examples of polynomial? What is the answer? These may be examples for polynomial. What is the answer? N power 1, n square, n cube, n power 0.5, n power 25. Next one, n power 0.75, n power 0.11, like that. Right? This is going to be polynomial. What is the exponential? These also let me give. 2 power n, 3 power n, 1.5 whole power n. Right? Like this. These are going to be exponential. Next one, constant. Every constant is constant. 5 also constant, 10 also constant, 20 also. Everything is big O of 1. Logarithmic, big O of log n. Linear, big O of n. Quadratic, big O of n square. Cubic, big O of n cube. Polynomial, exponential. And one more thing, I written all these things in increasing order. So it is the minimal one, right? It is the maximum one among all. Among all these people, it is the minimum one. It is the maximum. Can you say polynomial, exponential? Exponential is bigger, right? So, and one more thing. A special type of polynomial is known as linear. That is n power 1. A special type of polynomial, right, which is known as quadratic, right, n square. A special type of polynomial, right, cubic, right, which is going to be big O of n cube. For every polynomial, I cannot give the different name. Linear, quadratic, cubic, right? So like that, all this total group is called as, right, polynomial. So these are called complexity classes, right? Complexity classes. Some people are asking, sir, why are you explaining this also? What is the requirement? Sometimes in the option, they don't give big O of 1. They will give constant complexity. Sometimes in the option, big O of log n, they don't give. They will give logarithmic. Sometimes they will say, they don't say, right, n cube, right? They will say, right, polynomial, right? Please be careful. Sometimes they don't say 2 power n, they may say exponential. It is better to know, that is the reason I written. Complexity classes I written in the increasing order. This may be time complexity, this may be space complexity, right? Please be careful. Now if you are okay, let's give some examples on that, right? Complexity classes, right? Based on that, some problems are there, right? I will give one by one. I may say approximately, right? So maybe 15 problems maybe I will cover. Please you take care all these things. 15 problems maybe I will cover, right? Please you take care all the problems I am going to cover, right? Fine. Yeah, let's see first problem of asymptotic notation. Please be comfortable from now onwards. Until now, asymptotic notation definitions I said to you very clearly. Now from now onwards you will see many problems on the asymptotic notation. It is the first problem. Please be comfortable from now onwards. Indirectly, directly, how to use big O, how to use omega, how to use theta, I will explain to you with the help of all these problems, right? So from now onwards, careful. Whatever happened until now, it's okay. From now onwards, take care. Any very small doubt also there, you can ask me, right? I'm starting now, right? See the first problem. Example 1, see this. F of n is equal to log n base 2, g of n is equal to log n base 3. Then he is asking what is the relation between these two functions. Means he is asking what is the relation between these two. What is the meaning? Is it big O or omega or theta or small O or small omega? We have to explain. What is the relation between these two asymptotically, right? Asymptotic relation. If you want, I will write asymptotic relation. Relation between these two functions. Relation means asymptotic relation only. That is only our goal. No need to write again and again. So in algorithm subject, between these two functions, what is the relation, right? Means asymptotic relation only, right? Mostly many people know what is the answer of this. If anyone don't know, from now onwards, please take care. This function, what is the relation between these two asymptotically? So I am starting now. It is the log n base 2, it is the log n base 3. So I am explaining. See carefully now. See the carefully. Log n base 2, log n base 3. See this one. Log n base 2. Log n base 3, right? We have to see now. Log n base 2, log n base 3, we have to see now. Just let me explain one small line, right? Now one small thing I want to ask you. You only say, just by seeing this example, you will get to know what exactly this is. See this one, you only say log 100 base 2, how much? Log 100 base 2, how much? 100 can be written as approximately 2 power 7. Log 2 power 7 base 2, 7. Log 2 power 7 base 2, 7. Next one. Log 100 base 2 is 7, it's okay. Log 100 base 100. What is the answer? 1. Log 100 base 10. What is the answer? 100 can be written as 10 square. So 2. So again I am asking you. Log 100 base 2, 7. Log 100 base 10, 2. Log 100 base 100, 1. What is the meaning? I think all are log 100 only, but bases are differ. Base 2, base 10, base 100. If the base is small, bigger value will come. Log n, log n, log n everywhere, but base 2, base 10, base 100. Base is small, bigger value will come. Please be careful. You know very well, right? I think same story. Log n base 2, log n base 3, which is bigger? Base is small means big. This is the big value. This is the small value. Comparing these two, this is small, this is going to be bigger one because of base is small, this is going to be smaller one because of base is big, right? So smaller and bigger, it's okay, but asymptotically what is the relation? I am explaining now. Carefully listen, asymptotically what is the relation? You only say, it is the log n base 2, it is the log n base 3. Carefully listen what I am saying now. This can be written as, you know this formula is there, log n base 2 by log 3 base 2. There is a formula. Right? Log n base 2. One common base you bring. Common base is 2. Log n base 2. Log 3 base 2. There is a one formula. If anyone don't know this formula, please you take care. What is that formula? See this one. Log a base b is equal to, what is the answer? This is the formula for this one. Log a base b is equal to, see the formula? This is the formula. Log a base c by log b base c. This is the formula. Everyone know this, right? Using this formula I done, right? This can be written as, listen, this can be written as log n base 2 by log 3 base 2 is going to be 1.5. Log 3 base 2 is going to be 1.5. See this one, this is equal to log n base 3, which is equal to this one. This one. Right? Now, so from now onwards, if anyone asks, what is the log n base 3? Log n base 3 is nothing but log n base 2 by 1.5. What is the meaning? Log n base 2 if I divide by 1.5. Right? Log n base 2 if I divide by 1.5, I will get log n base 3. Now again I am asking, some people are asking how to get log n base 3? Nothing there. Log n base 2 divided by 1.5, you will get this. What is the meaning? Right? The meaning of this one is going to be log n base 3 if I multiply by 1.5, I will get this. Another way of saying log n base 2 divided by 1.5, I will get this. I think it is the correct time to ask you. It is the correct time to ask you. Please help me. Log n base 2, log n base 3. What is the relation? Log n base 2, log n base 3. What is the relation? Log n base 3, if you multiply by 1.5, then you will get the log n base 2. What is the meaning? E is smaller. Log n base 3 is smaller. That's okay. Smaller by how much? 1.5. So this person, log n base 3 is going to be smaller comparing with log n base 2 by 1.5 times, which is nothing but log n base 2 if you divide by 1.5, I will get log n base 3. I think by seeing this one, please give the conclusion. What is the conclusion? See the conclusion now. Log n base 2. It is the log n base 3. Log n base 3. Okay, now can you help me one smaller now? This is smaller or bigger? Smaller. Smaller by how much? 1.5. This is smaller by 1.5 time, right? So if you multiply by 1.5 this side, this is equal to this one. What is the meaning? If I multiply this side, log n base 3, if you multiply by 1.5 or more than 1.5, I can make this side bigger, indication that big O possible. Because this person is smaller by constant only. With the help of C, I can make this side is bigger. Next one. And one more thing. By default, who is bigger? It is the log n base 2. It is the log n base 3. Who is bigger? This person. Omega also possible. Because he is already bigger. Omega value 1, right? I think C value 1 you can take. This is bigger. C value here you take 2. 1.5 or more than 1.5. This side is bigger. Right? If you take the C value 1 or less than 1, right? C value is 1 or less than, C value 1 is enough, right? This side will be bigger because of big O, omega both possible. What can I say? Theta. Answer is going to be this one. Log n base 2 is equal to theta of log n base 3. I think it is the correct time to ask you, what is the relation between log n base 2, log n base 3? What is the answer? Both are asymptotically equal. Mathematically, if you observe, this person is smaller, this person is bigger. This person smaller by 1.5 times. If I multiply by 1.5, then both are equal. The relation, the difference between both the people is constant factor only. So, asymptotically equal. I want to say from this problem, this formula and how to compare. F of n, g of n, who is bigger? Both are asymptotically equal. Mathematically f of n is bigger, g of n is smaller. Asymptotically both are equal because g of n is smaller by 1.5 times only, means constant number of times only. Right? Now if anyone thinking that, sir, right, is it valid for all the people? I hope so. Please see, if you want, see this one. See this one now. Log n base 5. Log n base 7. What is the relation between them? Right? You know very well. Who is bigger? This person is bigger. By constant factor only. If you want, you can check. This can be written as base is small, bigger value. Comparing these two people, this person is bigger, it's okay. This person is bigger mathematically or asymptotically or what? You can see now. This thing can be written as, what is the answer? Log n base 5. Log 7 base 5. Means it is a constant. Right? So, if you see this side also log n base 5 there, this side also log n base 5 there, but one thing, this one, if you divide by this one, right, log n base 5, if you divide by log 7 base 5, then you will get this. Right? I am repeating once again. Right? I am repeating again now, please see this one. Log n base 5, log n base 7, log n base 5 is bigger. Right? Mathematically. But the difference between them is constant only. Some people are asking, sir, how? Log n base 7 can be written as log n base 5, log 7 base 5. It is a constant. What is the meaning? Log n base 5, if I divide by log 7 base 5, which is a constant, then I will get log n base 5. Comparing log n base 5, log n base 7 is smaller. Right? Some people are asking, sir, how? Log n base 7 can be written log n base 5 by log 7 base 5. What is the meaning? Log n base 5, if you divide by log 7 base 5, then you will get the log n base 7. That indication that is, right, log n base 7 is log 7 base 5 times smaller. Log n base 7 is log 7 base 5 times smaller. What is the meaning? This person is constant times smaller than this person. Now, can you help me now? Comparing these two, who is bigger? Log n base 5. How many times bigger? How many times this person is bigger? Log 7 base 5 times bigger. If you divide this person by log 7 base 5, then you will get this. If you divide this one log 7 by base 5, then you will get this. Indication that this person is log 7 base 5 times smaller. So, because of difference is only constant, I can write theta also. What is the answer? Log n base 5 is theta of log n base 7. Difference is only constant. Can you help me now? Which constant I should keep so that this side is going to be bigger or equal? What is the answer? Log 7 base 5 you keep. Right? This is going to be bigger or equal. If you keep the C value 1, then this side is bigger. So, difference by only constant, theta possible. Right? Please be careful. So, this is the first problem answer. It is the first problem answer. Right? Yes, now I am repeating now. Two functions are given. They are asking what is the relation between them. The relation between them is asymptotically both are equal. Mathematically f of n is bigger. Asymptotically both are equal. So, theta possible. Theta possible means big O possible, omega possible. Can you say which value big O is possible here? What is the answer? 1.5 or more than 1.5. Which value omega is possible here? 1. Big O omega possible, then theta. Same thing I said in the form of, right, log n base 5, log n base 7. Log n base 5 is bigger. Bigger by how many times? Log 7 base 5 times. Right? If you divide this one by log 7 base 5, then you will get. So, because of difference is only constant, theta possible. Right? This is the first problem for asymptotic notation. If anyone having small doubt also, please you take care. This is the first problem. Let's go to the one more problem. See this problem also. It's the second problem, right? See this problem also. Example 2. Read this problem properly. So, I think 4 functions are given, f1, f2, f3, f4. There are 4 functions are given. Now, they are asking, arrange all these 4 functions in asymptotic increasing order. Arrange all these functions in asymptotic increasing order. Means you have to write all these 4 functions into asymptotic increasing order. Asymptotic increasing order. Right? We have to write. We'll see now. Right? We'll see. It is a very nice problem. Please you make sure that whatever I am going to say, please listen now. I'm starting. See everyone now. One nice explanation is there. Let me check. See this one. N and log n. Who is bigger? You only say n and log n, who is bigger? It is a nice problem. I have to keep all of them in asymptotic increasing order. I will do now. F1 and F2 I am comparing. Can you say n and log n, who is bigger? Everyone now. N bigger. N is going to be linear. Log n is going to be logarithmic. N and log n, who is bigger? N bigger. That's okay. Next one. Some people are asking, n and log n bigger, we know that, right? But what about this one? N and log n, that is fine. N and log n. But it is not log n, it is the log n square. Then who is bigger? N and log n, linear and logarithmic, linear is bigger, everyone know. Right? Because this is bigger and this is smaller. If you do log n whole square, right? Then n and log n square, who is bigger? N and log n square, who is bigger? Now, if you want, you can check n and log n square, who is bigger is if you want to know, right? Supposition that 2 complex functions are given, 2 complicated functions are given. If you want to know who is bigger, right? If you can give answer directly, well and good. If you are unable to give, just apply log both the side. I am unable to decide who is bigger in these 2, right? If you are having small doubt also, complex functions are given. Difficult functions are given. If you are unable to decide which side is bigger, which side is smaller, most probably what you will do is apply log both the side. Apply log here, right? If you apply in these 2 people, who is bigger, I don't know. Apply log both the side. It will become log n. This will become 2 into, right, log n. Forget about 2 constant. One side, if you apply log both the side, it is a log n, it is going to be log n. Everyone now, log n and log n, right, log n bigger. So after square also, still n bigger. Right? Let me see one more interesting answer. It is a n. It is the log n whole power 3. Then what is the answer? Who is bigger? If you have doubt, apply log both the side. It is the log n. This is going to be 3 log n. Log n and log n, everyone now. Log n bigger. So what I want to say, linear and logarithmic you take. Right? Linear is bigger. Logarithmic square it, still linear bigger. Logarithmic cube it, still linear is bigger. If I continue something like n, right? Log n whole power 100, right? Then also is bigger. If I continue n log n whole power 1 lakh time, right? Then also it is bigger. Right? Please be careful. If you have doubt, apply log both the side. And one more interesting answer. Some people are asking, right? So linear and logarithmic square it, cube it, whole power 100, whole power 1 lakh, still n bigger. Some people are asking, sir, is there any chance of reverse will happen? Nothing. This is one n. Right? This is the log n whole power. See this one. You done whole power 1, whole power 2, whole power 3, whole power 1 lakh also. Still n bigger. Right? Suppose if you do log n whole power, right? Some function times you done. Not constant time. Function times you done. If you do function time, you only say apply log both the side. It is the log n. This is going to be log n into log n. This is only log n. If you apply log, here log n into log n. Then is bigger. If you do function time, there is a limit for everything. Take the one smaller one, right? I am repeating once again now. Take one bigger, take one smaller. Take one bigger, take one smaller. Smaller one, increase. Still, this is bigger. Next one, smaller one, cube it. Still, bigger is bigger. Smaller one, whole power 10, still bigger. Continue. If you do function time, there is a chance of reverse will happen. Right? Actually, smaller one, if you keep on increasing, right? It may not change the behavior. But when you do function time, there is a effect. This may be the case. N and log n bigger. N and log n square, n bigger. N and log n cube, n bigger. N and log n whole power 100, then also n bigger. Log n whole power 1 lakh, then also n bigger. But when you do function time, it reverse. See this one. If you apply log now, it is a log n. It is going to be log n into log n. And one more, 2 difficult functions are there. If you are unable to compare, right, apply log both the side. It may simplify a little bit. Right? Blindly don't apply. Difficult functions are given. Complicated things are given. If you are unable to decide, then apply log both the side. It may simplify a little bit. For everything, if you apply the log both the side, there may be a serious problem. Right? So whenever complicated things are given, difficult things are given, if you are unable to justify who is bigger, who is smaller, apply log both the sides. Right? That may solve your problem. Please be careful. Can you help me now? In this problem, you only say n and log n power log n, who is bigger? Right? N and log n bigger. But if you do function time, something like that, right? Then this is going, right? Then I think f2 is going to be bigger. So I think, right, comparing the n and this one, f1 and f2 bigger. That's okay. Now come to this side also. Log n and root n. Let's check. See this one? Log n and root n. Who is bigger? Log n and root n. Who is bigger? Right? If you can give answer directly, it's okay. But if you are unable to give, you can apply log both the side. Apply log both the side. It will become log n. This is 1 by 2 log n. This is, if you apply log both the side, this is going to be log n. This is going to be 1 by 2 log n. Forget about constant. It is the log n. This is bigger. Try to remember this one. Log also will decrease value. Root also will decrease value. If anyone having small doubt also, assume that I have 1000. Can you help me now? What is the log 1000 base 2? So if you have small doubt, let me check this one. Say n value 1000. N is this. Right? Can you help me now? What is the log 1000 base 2? Log 1000 base 2. I think 1000 can be written as, what is the answer? 2 power 10 is going to be 1000. 2 power 10 is 1024 approximately. 2 power 10. Log 2 power 10 base 2. What is the answer? 10. Next one, what about this one? Apply root. Root 1000 is approximately maybe 33. right? 30 into 30, 900, 33 into 33, approximately like that. So can you help, n value 1000, root is going to be 33, right? But log is going to be 10. Can you help me one small, mostly who is bigger? I think root is bigger, right? And one more thing, if you want to find out who is smaller, who is bigger, please, my sincere advice, if you want to find out who is smaller, who is bigger, my sincere advice, please don't substitute values like this. Don't substitute the values, right? That may give sometimes wrong answer, because asymptotically constant doesn't matter. That is the reason. At any point of time, if you want to compare two functions are, what is the behavior and all, don't substitute the values, right? Just do like this. Maybe you can apply log. Complicated functions are given, difficult functions are given. If you are unable to decide who is bigger, who is smaller, just simplify by applying log both the side. Apply, right? It is going to be log n. It is going to be 1 by 2 log n. Forget about constant. Log n is bigger. So I can say that comparing these two, who is bigger? Root n. If some people are asking, sir, how can you say root n is bigger? I given some small, right? I think only for understanding purpose I given this. But in examination, please don't do by substituting values. Because in asymptotic notation, every constant is same. Asymptotic notation 10 also same, 20 also same, 30. Constant is constant. Constant is nothing in the asymptotic notation. That is the only reason. Don't substitute values, right? To get some idea, I given that, right? If you want to know who is smaller, who is bigger asymptotically, just apply log. Here also I tried applying log. If really required, apply log. But don't blindly apply log every time. So I think now if you are comfortable, can you help me now? In these two people, who is bigger? This one. Root n is bigger. Next log n, that's okay. Can you help me in these two people, who is bigger? Log n is bigger. Afterwards n. If you are comfortable, overall give the answer to me. Overall, who is bigger? Can you say who is bigger here? Root n. Who is bigger here? Log n. Let's check here. Here root n is bigger. Here log n is bigger. You only say now who is the bigger now? F4 is bigger in these two. F2 is bigger in these two. Now F2 and F4, who is bigger? If you can give directly answer, well and good. If you are not able to give these two, is bigger and all, right? Apply log now. If you apply log here, what is the answer? Log n into log n. But this one, 1 by 2 into log n. Can you help me now? What is this value? Right? 1 by 2 into log n. This value, log n into log n. Can you help me now? Right? This is going to be 1 by 2 log n. This is going to be log n into log n. Right? Fine. I think log n both the side cancel. Can you say what is left out? Log n. But here constant. So log n is bigger. This side, if you apply log for the F2 here, log n into log n. This is 1 by 2 log n. Log n cancel. The remaining left out here is log n. Here is constant. So log n bigger. Please be careful. It is the number one in the order. Is the bigger one. Among all these four people, right? This one is bigger. F2 is bigger one. Let me write the bigger one. Afterwards, we will write in the increasing order. Is the number one which is bigger. Can you help me now? In the left out people. Let's check here. Right? Let's check. Can you help me in this group? Who is the bigger? Root n. In this group, this is already confirmed. F2 already confirmed. In these two people, F3, F4 bigger. Now let's check here. F1 and F4. Can you say what is the F1? N. What is the F4? Root n. Can you help me? N and root n, who is bigger? N can be written as root n into root n. This is only root n. I think it is bigger. It is the 2. It is a n. It is the root n. This n can be written as n into n. Sorry, this n can be written as root n into root n. So it is the root n into root n. It is simply root n. This is bigger. So 1, 2. This is the next one. So I given the 1, 2, 3, 4, right, in the decreasing order, but I want increasing order. Can you help me now? What will be the increasing order? I am writing increasing order asymptotically. Increasing order asymptotically. Can you help me? Which is the smaller? Increasing order I want. Which is smaller? Log n. Next smaller, root n. Next smaller, n. Next smaller, log n whole power log n. Right? This is the order. To this problem, answer is going to be increasing order asymptotically. Log n, root n, log n whole power log n. Now listen, the purpose of this problem is going to be these two, n and log n power log n, how to compare. And one more, log n and root n, how to compare. So asymptotical, who is bigger, who is smaller, we want to know. I think I explained to you clearly. Please you take care. Right? Fine. So asymptotic increasing order I written. Who is the first bigger? This one. F2 is first bigger. F1 is the next one. F4 is the next one. F3. In the increasing order you want. Right? Like this. Log n, root n, n and log n power log n. Yeah, let's see the next problem. Example 3. Yeah, see this problem also. F of n is equal to n factorial, g of n is equal to 2 power n, h of n is equal to n power n. Right? Three functions are given. They are asking what is the relation between these three functions. Between these three functions, what will be the relation they are asking? Right? We will see now. We will see. Right? Mostly you know the answer for this. If anyone don't know, please see once. Right? See, there is a, I think, n factorial. Right? 2 power n, 3 power n. Like that, totally three functions are there. We have to find out what the relation between them. Right? I will try this. See this one? See everyone? See everyone now. 2 power n, 3 power, right sir? 2 power n. One more is n power n. N power n. 2 power n, n power n. You only say 2 power n, n power n. You only say, right? This is also n time, this is also n time. Both are n time. See this one, 2 into, 2 into, 2 into, and so on. Right? N times. Here n into, n into, n into. How many times? N time. See this one. Everyone in front of n, 2 is nothing. In front of n is a function. In front of n, 2 is nothing. Right? So small thing is multiplied n time. Big thing is multiplied n time. Right? Everyone know this one. Comparing 2 power n, n power n. N power n is far greater. Right? It is the, see, n time, here also n times multiplying, here also n time multiplying, but big number is multiplied. Big number is multiplied. So no doubt at all this is greater. Everyone know this. Right? Not only that, not, see this one, not one time greater, not two time greater, every time greater. Not one time greater, two time greater, every time greater. So this is going to, there is no constant difference between them. Big functional difference is there. Right? Please be careful. Right, fine. So if anyone having small doubt, try to always remember, try to do meaningfully, try to do mathematically. Don't do by-hearted kind of thing. Some people, they will apply the blindly log. That is right. That is also okay, but sometimes it may create some trouble. Don't apply blindly every time log. Right? If really required, whenever all paths are closed, if you think that, right, I cannot solve in any other way, then only go to apply log and all. Because sometimes it may create trouble. The reason is asymptotically. That is the reason for that. Because of asymptotic notation, constant you don't think, right? It may create some trouble sometime. Most of the time, try to avoid applying log. Try to avoid applying log. Right? Worst case, you can apply log. First try to use brain, right? Afterwards, right? If at all, you tried your level best, still not possible, then maybe you can apply log. Mostly that is also correct, but one or two times there may be some problem. Right? I will say that case also. Right? Please be careful. So 2 power n, n power n. See this one. N times, right? 2 into 2 into n times, n into n. Small number multiplied n time, big number multiplied n time. No, everyone know this one. N power n is far greater. Now see the one more thing. See the one more thing. N factorial. See the n factorial. What is the meaning of n factorial? N into, n minus 1 into, n minus 2 into, n minus 3 into, and so on. Lastly 2 into 1. This is the n factorial. If you observe clearly, see this one. If you observe clearly, it is always 2 multiplied, but here always n multiplied in terms of n only. Right? Comparing 2 power n, this n factorial is far greater. Because see this one every time greater. See this one every time. But if you see the n power n and n factorial, what is the answer? Here n, here n minus 1, here n minus 2. So I think if you observe the n power n and n factorial, every time little bit decreasing. Every time little bit decreasing. Not one time. Every time little bit decreasing. One time okay, two time okay, and I think n times decreasing. So comparing n factorial and n power n, right? N factorial is far greater. Because it is not one time change, right? Every time there is a less. Because if every time there is a less, overall there is a big less. But here see this one, here if you see simple number, small number 2 multiplied n time, right, see this one, 2 power n factorial if you observe, here every time 2 multiplied, here every time almost n multiplied, right, comparing 2 power n factorial is far greater. Comparing n power n factorial, right, so n power n is far greater, everyone know this, right, because it is not one time change, many time. It is an expression, right, expression having internally this meaning. Can you say finally, what is the conclusion? And one more thing, between them, not constant difference, big function difference. Big function difference, because one time difference is not there, n times difference is there. So finally this may be the conclusion. Can you see among all those three, which one is the smaller one, 2 power n? Which one is the middle one, n factorial? Which one is the next one, n power n? This is the relation between them. Right? So n power n is, because here 2 multiplied n time, here n multiplied n time. Here also n multiply n time, right, but little bit decreasing. Because of little bit decreasing, right, so it is a less than n power n, right. But one thing is true, here always 2 multiplied, here always almost n multiplied, right. So finally comparing 2 power n factorial is bigger, comparing n factorial n power n is bigger. So can you help me know what is the relation between all these three things? This is the relation. Can you say which one is smaller among all? 2 power n. Bigger, n power n. N factorial is going to be middle. So if you want, I will write the asymptotic format also. If you want, you can see this one. 2 power n is big O of n factorial. One more, big O of n power n. Next one, see this also. See this one also. N factorial is big O of n power n. N factorial is big O of n power n. If you want, there is one more interesting answer. If you want, you can keep small o also, because there is no constant which can make both as equal. There is no constant which can make 2 power n and n factorial. So that is the reason it is not theta. It is not theta, right? It is only big O. What is the meaning? Only big O. Omega not possible. Only big O here, omega not possible. Big O omega is there, then theta. Only big O is possible here, omega not possible. That indication that, can you help me now, one small line? Can you help me one small line now? Right? So there is no chance of this person is going to be, right? Both are going to be equal. It is strictly, I think I can say that it is a small O. Right? So this is the relation between all these three things. And one more thing I wanted, there is no chance of theta, because they are, right, their function factor, they differ. There is no chance of theta. Only big O, there is no chance of theta. What is the meaning? Omega not possible. Big O possible, omega possible, then theta. Theta means equal. Now can you help me now? Big O possible, omega possible, then theta. Right? Big O is possible. What is the meaning? Big O is possible means less than or equal to. Big O is possible means less than or equal to. Right? Now can you help me? Omega also possible, greater than or equal. That indication that equal. Right? Now let me ask one small now. Whenever you say big O less than or equal, omega also greater than or equal, then equal. Suppose in the omega fail, what is the meaning? Greater than or equal to fail. If both possible, then theta means equal. Big O possible, omega not possible, indication that there is no chance of equal. Both possible, then equal. One only possible, less than or equal to possible, but greater than or equal to not possible means equal fail. Equal fail means less than. Equal fail means less than, which is nothing but small O. Now I'm saying one more small line. These two people, there is no chance of making equal. Equal not possible means less than or equal to remove equal. So it is to be frank, it is a small O. It is also small O. It is also small O. Difference is not constant. Difference is function. Right? That is the reason you cannot write the theta. Theta not possible. Big O possible, theta not possible means equal, no chance. These are actually small O. That is the reason. See, I am not written the less than or equal to. I written the less than. Between these three people, what is the relation? Like this. Right? If you reverse it, then you can write omega also. But see, as it is if you keep big O only possible, omega not possible. If you reverse it, omega possible but big O not possible. You know this very well. If you reverse it, right, big O reverse is omega only. What is there in that? Right? So big O possible, but as it is big O possible, omega not possible means there is no chance of theta, means equal not there, means it is a small O. It is small O. Please be careful. To these three people, what is the relation? Right? This is the relation. See this one. Comparing these two people, n factorial is bigger. Comparing these two people, n power n is bigger. Right? Comparing these two people, n power n bigger. Comparing these two people, n factorial is bigger. So if you see the relation, right, it is like this. So in terms of the asymptotically, this is the relation. Right, it is actually small o. And one more thing I want to ask you. Small o means big O also. Big O doesn't mean that small o. I am repeating once again. Small o means big O also. Big O doesn't mean that small o. What is the meaning of big O? Less than or equal. Anyone can satisfy. But small o means, right, only less than. Less than satisfied. Less than or equal to also will satisfy. Less than or equal to satisfied. Less than may not satisfy because equal may be the reason. I am repeating once again. See this one. See everyone. Small o satisfied. Big O also will satisfy. Right? Big O satisfied. Small O may not satisfy. And one more here. Here small o. What is the reason? Here small o. What is the reason? Between two people, big O possible. Right? Omega also possible. Then theta means equal. But big O possible. Omega not possible. Means equal not there. Equal not there means only less than. Means small o. Right? So please be careful. These are some powerful functions. They may come again and again. Right. Now let's go to the one more problem. See this also. See this is one more problem. Example 4. Example 4. See this also. F of n is equal to 3 power n. G of n is equal to 5 power n. What is the relation between these two functions? Right? Can you help me now? 3 power n, 5 power n. Who is bigger? Let me write now. 3 power n, 5 power n. Everyone, both are exponential. Who is bigger? 5 power n is bigger. Everyone. See this one 3 into n time. Next one here. 5 into n time. Right? 3 power n, 5 power n, everyone know 5 power n is bigger, that is okay. Both are everyone know. What are the both are? Both are exponential. 3 power n and 5 power n, both are exponential. Right? And one more thing. See, some people are asking, sir, these two are exponential, it's okay. Comparing 3 power n, 5 power n, 5 power n is bigger, that is also okay. But what is the difference between them? See this one? I am trying to give difference also. See this one, it is the 3 power n. It is the 5 power n. See the difference. Right? This 5 power n can be written as 3 into 5 by 3 whole power n. Because 3 cancel, 5 only will come. Just nothing. I'm not doing anything. I'm writing 5 power n in terms of 3 power n. This can be written as 3 power n into 5 by 3 whole power n. Right? 3 power n cancel. If you want, you can check. So this 5 power n is bigger by this much. 5 by 3 whole power n, which nothing but 1.6, maybe something like that. Right? 3 ones 3, remainder is 2, 3 6 18, 1.3, 1.6, 3 6 18, 1.6 whole power n. So definitely, right? Can you help me now? 3 power n, 5 power n, who is bigger? 5 power n is bigger. How many times bigger? 5 by 3 whole power n times bigger, which is nothing but 1.6, right? 6 maybe. 6 whole power n times bigger, which is nothing but a exponential time bigger. 5 power n is bigger comparing with 3 power n, exponential time. Not constant time, exponential time. See, 1.6 whole power n time, exponential time bigger. Now can you help me now? Now how many people will be between 3 power n, 5 power n? 3 power n, 5 power n, big O possible? Yes. Omega possible? No way. Omega not possible. Because everyone know 5 power n is bigger. Can you help me know what is the meaning of big O? Right? I think there is a C which can make this side greater. C is equal to 1, right side is greater. Next one, there is no C which can make left side bigger. That is the reason this is failed. Only big O possible, right? 3 power n is big O of 5 power n. Omega also possible, then I could have written theta. Theta not there means what is the meaning? Equal not there. So this can be written as 3 power n is small o of 5 power n. It is a small o. It is a small o. Please be careful. Big O possible, omega also possible. Both there, then I could have written theta. Theta means equal. Equal means, right? You can write any order. But because of here only big O possible, omega not, only big O but not omega. What is the meaning? Small o. Only big O means what? Less than or equal to. Small o, big O means less than or equal to. Omega also possible, greater than or equal to means equal. But when you say omega fail, equal fail means less than, which is nothing but small o. Right? Fine. Now again I am repeating now. So small o satisfied means big O also will satisfy. Big O satisfied, small o may satisfy, may not satisfy, but here satisfying. Here big O satisfying, right? Small o also satisfying. But it doesn't mean that big O satisfied, every time small o will satisfy. Small o means big O. Big O doesn't mean that small o. Right? Fine. I'm thinking you're okay. Now by seeing this one, people are thinking that both are exponential. Difference is only constant, no function. Because the function constant is there, right? Left is this one, right is already bigger. Left you cannot make bigger, means omega not there, means theta not there, means equal not there. So less than or equal to equal not there, means less than, means small o. Small o, right? Please be careful. If I don't say this problem, you may think that both are exponential equal. No. Both are exponential equal. No. Right? Fine. Can you see what is the relation between them? This is the relation. 3 power n is big O of 5 power n. Next one, 3 power n is small o of, right, 5 power n. Right, 5. These two are right. And one more, this is wrong. 3 power n is omega of 5 power n is wrong. Because this is wrong, this is also wrong. 3 power n is theta of 5 power n is also wrong. And one more, I am giving the clarity here. See, small o satisfied means big O also will satisfy. Big O doesn't mean that small o. Right? This is the answer for this problem. Let's see this problem also. Let's see this problem also. I think example 5. Let's see this problem also. Example 5. 4 examples are over. It is the 5th example. Make sure that you see. Try to get every problem as much as possible. Right? In some problems, maybe 1 or 2 doubts are there. Revise again. Ask your friends. You ask me. And try to remember that. So please stop begging. Please stop asking first of all. Please try to clarify yourself only first. Listen again and again. Other people, when you depend on others, they may help, they may not help. Best idea, listen properly. I used to repeat again and again. You should help to other people, right? You cannot ask the others. Right? Sometimes maybe it is possible, when you ask some doubt, they may give. If you keep on asking again and again, they may not give the answer. Best idea, please listen. Please learning the capability of listening. Try to listen as much as possible. If you are not clear, again repeat. Write the notes properly. Because if you write the notes properly, your language you can easily understand. Right? Fine. That's okay. Now come to the next one. Example 5. F of n is equal to log n factorial. G of n is equal to n log n. Relation between these two functions. Right? Now there is one interesting thing is there. I want to say that is the reason I given this problem. Right? Let's see this. See everyone. It is very interesting one. See this one. N factorial. N power n. Who is bigger? N factorial, n power n, who is bigger? N power n is strictly bigger because here see this one, every time little bit decreasing. Here every time is greater. Here every time see this one, n into n minus 1 into n minus 2 into n minus 3. Here many times smaller. Here many times bigger. That is the reason. N power n is strictly greater. Not big O. Not less than or equal to also. It is a small O. It is a small O. N power n is strictly greater than n factorial. Please be careful. Right? N factorial is strictly less than n power n. Right? That's fine. That's fine. Now see the answer. Now see the answer now. Log n factorial. That is fine. Log n factorial. Log n factorial. Apply log here also. Apply log both the side. Log n factorial. This will become log of n power n. Right? This will become so log n factorial. That's okay. This will become what is the answer? N log n. N log n. Please be careful. Please be careful. After applying log, this is theta. Only for this, it is a special case. Please be careful. See this one. These two, the relation between these two people is less than. After applying log, log n factorial is theta of n log n. Right? So after applying log, there is a difference between them. No doubt at all, there is strictly, right, less than is there. After applying log, they both are equal. Using Stirling approximation. Using Stirling approximation. Please find out what is the meaning of that. Right? Using Stirling approximation, see this one. These two are equal. Right, this one, if you apply, there are two functions, the relation between them is, right, less than. After applying log, they both may be equal. Using Stirling approximation, they both may be equal, maybe not every time. This one you remember. Using Stirling approximation, log n factorial is equal to n log n. Log n factorial is theta of n log n. Before applying log, this is the relation. After applying log, this is the relation. I applied log both the side. Right? Then it became both are equal. Some people are asking, before applying log less than, after applying log how equal? Right? Using Stirling approximation for this particular, these two people, it is possible. Some people are asking, sir, can you give one more small example? I am giving. See this one? I am giving. Using Stirling approximation. So, listen, I am giving one more example, how this is possible. Using Stirling approximation, it is possible. Some people are asking, sir, can you give two functions? Before applying log less than, after applying log both are equal. This may be the answer. See everyone? See everyone now. 2 power n. 2 power n, 3 power n. 2 power n and 3 power n. Right? If you see, it is the less than. If you see, this is the less than. Now, if you apply log, what is the answer? N log 2 base 2. This is, right? N log 3 base 2. Which is going to be log 3 base 2 is a constant, log 2 base 2 also constant. See this one, both are equal, theta. Theta. Before applying log, strictly less than. After applying log, right? If you see after applying log, forget about constant, n is theta of n. These small constant taken care by C. So what I want to say, before applying log, there is a less than. After applying log, right? There is a theta between them, right? It does not happen every time. It does not happen every time, please be careful. Right? So, using Stirling approximation, it is possible. Right? This is C. Because of small constant only difference. Right? It is possible. After applying log, constant only difference. Before applying log, 3 power n is function times bigger. After applying log, constant only difference. Then theta possible. Right? Theta possible. So, I want to say that there are some people, before applying log less than, after applying log there may be a theta. This is the example, right? Using Stirling approximation. What is Stirling approximation? Please find out by yourself. Google out, you will get the answer. Right? Some people are asking, sir, can you give one example? Can you give one example how it is possible? I given. 2 power n, 3 power n, 3 power n is bigger. Constant, function times bigger, not constant times also. Function times bigger. If you apply log both the side, then constant only difference is there. Theta possible. Before theta not possible, after theta possible. Because before is function times bigger, that afterwards is constant times bigger. This is the reason, right? Something like that. But here reason is Stirling approximation. Now can you help me now? What is the relation between these two people? What is the answer? Before applying log n factorial and n power n, right? N power n is strictly bigger. After applying log, both are equal. Both are equal. Some people are thinking that every time this is hold good. No. If you want, you can check. Every time it cannot hold good. Small example. See this one. Small example. N power log n. Small example. Every time it cannot possible. N power log n. N power n. Who is bigger? N power log n. N power n. Who is bigger? N power n is bigger. Because it's the log n times only. It is the log n times only. N log n time. But this is the n time. This is bigger. Apply log. Apply log. What is the answer? Log n into log n. What is the answer? Log n square. Log n into log n. Log n square. It will become n log n. Right? Still it is bigger. So, before applying log less than, after applying log also less than. Most probably, listen, between every two people, before applying log whatever is there, after applying log also same thing will be there. One or two people may change, right? He changed because of Stirling approximation. That is the reason I am saying to remember. That is the reason I am saying remember. From today onwards, if anyone asks you, A less than B, right? Log A, log B, that is also less than B. Until unless something specialty is there like this. This one only remember. This one only remember because it is something special. Remaining all, if anyone asks you anything, do manually. Whatever they are saying, do manually. Accordingly, take the action. Right? So, see this one. N power log n is less than n power n, everyone know. After applying log, it became log n square. It became n log n. Still it is. Right? So, if anyone asks you, A less than B, what about log A less than log A and log B? What is the answer? Just to do and check. If something like this one, right? Using Stirling approximation, you can say directly answer. If something else, right, do yourself and do. Right? I hope you are okay. Can you say for our problem what is the answer? Both are equal using Stirling approximation. Right? Most of the time it is not possible. Most probably like this. Sometimes, right? Because of Stirling approximation, it may be possible. Right? I given one more example. See this one. Before applying log, function factor bigger. After applying log, constant factor only bigger. So theta possible. You cannot do generalization. Generalization mostly this only. This is the generalization. Right? A less than B, log A less than log B. Mostly it is possible. Because of Stirling approximation, equal possible. Right? So this is the constant factor only difference, equal possible. For our problem, answer is going to be both are equal. Right? Let's see the one more problem. Sixth problem, right? See this problem also. What they are asking in this problem? I think 8 functions are given. F1, F2, F3, F4, F5, F6, F7, F8. Total 8 functions are given. They are asking all these functions arrange asymptotic ascending order. Means increasing order. If equal, it's okay, right? So increasing order or ascending order, right? You have to arrange all of them in the increasing order or ascending order. So how to do that? Let me try this. Whatever is possible, try. Can you say among all these people who is bigger? Among all these people who is bigger, you know very well. Worst case apply log. If you are unable to decide, use first of all your mathematical skills first too. If you are unable to do that, right, you can apply, right? You can apply lastly log in. Log apply both the side, it will simplify. Log will, if you apply log between two complex people, right, it will simplify. Worst case, you can apply log. First to do mathematically if possible, right? Suppose you are not getting mathematical way, right? Lastly, you can apply log, right? Please be careful. Let's start. Among all these people, who is bigger? Right, everyone among all these people who is bigger, n power n is bigger. This I think is the larger one. Right, is the larger one. Let me write now. Let me give number 1. Number 1 means larger. First larger. Can you help me now? N factorial. N power n is the first bigger. It's okay. What about n factorial? N factorial n power n is almost close. Everyone know that. Here little bit decreasing every time, here not decreasing, right? But here it is also n multiplied almost every time. Here also n multiplied almost every time. Here also n multiplied almost every time, but little bit decreasing. That is the reason there is a difference between both the people. But one thing, comparing this person is smaller, but very close relation is there. This may be 2, I am thinking. If any change is there, we will do within few minutes. It is the number 2. N power n and n factorial almost close. The n factorial is smaller, no doubt at all. N power n is bigger, that is also okay. Because of in the n factorial also every time n multiplied, right? So I think after this, right, this one may be bigger. I am thinking like that. If any change is there, within few minutes I will change. Right? That is the number 2. First larger, second larger, fine. Right? But one thing everyone, what is the answer? These two are equal, everyone know. These two are equal. What is the number I will give afterwards? But these two are equal, you know. That's what we discussed until now. These two are equal. What is the position? We will give within few minutes. Log n factorial and log n both are equal. That's okay. Next one. Can you help me one small line now? Right, in the previous problems we seen. See this one? It is the log n time. It is the root n time. n multiplied n log n times only this one. It is going to be root n time. You only say log n root n. Who is bigger? I think root n is bigger. This is the next bigger maybe. And one more thing I want to ask you, please listen, interesting answer. Comparing these two people, n power log n and n power n, who is bigger? N power root n. N power log n power root n bigger. Next one, log n whole power n. See this one, log n whole power n and this one, who is bigger? This is the n power log n. This is going to be log n power n. Who is bigger in these two? Next one, 2 power n. Right? We will see one by one. Right? Let's check here. Let's check. 2 power n. I think everyone, it is the number 1, it is the number 2, assume, right? I think what about this one? If you want, you can keep the number 3, but before going to that, please check once. Let me check. Can you apply log? Complex functions you can apply log. Can you apply log here? If you apply log, what is the answer? Root n into log n. This is going to be n. It is going to be root n into log n. Let me write now. This is let me write now. If you apply log here, root n into log n. What if you apply f4 log n? What is the answer? N log 2 base 2. Right? Next one. This n can be written as root n into root n. Root n cancel. This side is log n, this side is going to be root n. I think who is bigger? 2 power n is bigger. Comparing n power root n, 2 power n is bigger. Right? This is going to be n root n. This is going to be 2 power n. So who is bigger? I think 2 power n is bigger. Right? Fine. I think see, whenever by comparing F4, F3, F4 is bigger. F4 is bigger. If you say that, comparing this also is bigger because n power log n power root n is bigger. I think comparing this person is bigger. That is also okay. And one more thing. See the interesting answer. N power log n is smaller than 2 power n. N power log n is smaller than 2 power n. You only say, what about n log n? It is simply n log n. That is going to be n power log n. It is the n into log n. That is going to be n into log n time. Right? No doubt at all. 2 power n is bigger than these people also. Because these two people are lesser than this. It is the n power log n. It is simply n into log n. You only say this one. 2 power 5 is bigger or 2, right? 2 into 5 bigger. 2 power 5 is bigger. 2 into 5 is smaller, everyone know. So this is bigger. F1 is bigger than F7. F1 is bigger than F7. Right? Please be careful. And one more. What about this one? Let's check. What about these two people? Let's check. What about these two? If you apply log here, what is the answer? If you apply log here, n into log n square. If you apply log here, it is going to be n into log n square, but that is only n. That is only n. Apply log f2 and f4. Let me write now. f2, what is the f2? Log n whole square. This is 2 power n. Apply log both the side. It is going to be, sorry for this one, it is the log n whole power n. It is the log n. F2 is going to be log n whole power n. It is the 2 power. Now apply log both the side. N into log n square here. This is going to be n. N cancel. It is the log n square. This is bigger. So, can I help you in comparing F4, F2 bigger. Comparing F4, F2 bigger. Now, let's start now. Numbers. It is the number 1. It is the number 2. Right? It is the number 3. It is the number 3. Next one. It is the number 4. It is the number 4. I think in these two people who is bigger, it is this one. It is the number 5. Next one, it is going to be number 6. It is going to be number 7. These are, I think, last people. 2 people both are equal. Totally 8 functions are there. Until number 7 we are given the answers. Until number 7. Right? Now I think this is the, right? I given the numbers from bigger one to smaller one. Now one more thing, while doing this entire procedure, first I tried to do meaningfully, using my mathematical skills I tried. When I felt that this is very difficult and all, worst case I applied log. See this one, I applied log here. Complex functions you can apply log. Small functions don't apply log. Complex functions you apply log. Small things don't apply log. See this one, these are n power root n. Power should be there. Power should be there. Complex things you can apply log. Small things don't apply log. See this one, I think it is a complex one. When you felt that really difficult, then apply log. Here also I applied log. Mostly log will solve the problem, but don't misuse it. Right? Fine. This is the order. Number 1, number 2. But you want in the increasing order or decreasing order? Just write increasing order, reverse it. What is there in that? Right? It is up to you. This is the way. Right? Now can you help me one small line? Please say all these things. Right? Decreasing order. Let me write the decreasing order first. Afterwards you can reverse it. You will get the answer. Can you say decreasing order? Means who is the number 1? We are already given also. Number 1. Number 1. Who is that? N power n. Number 2. Where is the number 2? N factorial. Number 3. Number 3. Log n whole power n. Number 4. 2 power n. Number 5. n power root n. Number 6, n power log n. Number 7, n log n, log n factorial. Right? These are. Right? So, if you want ascending order, you can write ascending order. Ascending order. You only say, who is the number? Reverse it. Reverse it. What is the answer? N log n. Log n factorial. It is the number 1. Number 2, n power log n. Number 3, n power root n. Number 4, 2 power n. Next one, log n power n. Next one, n factorial. Next one, n power n. This is the ascending order. That is the descending order, it is the ascending order. Everyone know this. Everyone know. Right? This is the answer for this problem. If those people who got this problem, most of the things you can easily say which one is smaller, which one is bigger. Right? Fine. You are okay now? Fine. Right. Let's see the next problem. So until now I think I said 6th problem. Right? It is the 7th problem. Right? It is the 7th problem. Right? Read this problem. So please be comfortable. All the problems whatever I am going to cover in the classroom, they are mostly enough. Right? After class is over, if you want you can do some more practice also, but whatever I am saying in the classroom, mostly they are enough. Right? Let's see the 7th problem. Right? Read it. Find true statements from the following. Right? Out of these 4 statements, which are true, which are false, you have to, right, find out. Read the options also. Right? And this year GATE examination, you know, right, multiple select type questions also there. Means more than one answer may be there. That is the reason. So you cannot say one is true, right, remaining is false and all. Please be careful. Right, let's see this. Find true statements from the following. From all these 4, which is the true statement, you have to find out. Alright, read them. 2 power n plus 1 is big O of 2 power n. B. 2 power 2n is big O of 2 power n. C. If a less than b, then n power a is big O of n power b, where a, b greater than or equal to 1. D. 4 power n by 2 power n is equal to big O of 2 power n. Right? These are the things. Right? So let's try. What is the option A? Right? Option A. See this one, option A. I am proving the option A. Please see this. So 2 power n plus 1 is big O of 2 power n. Right? Let me write. What is the meaning of this one? Right? The meaning of this one is 2 power n plus 1 less than or equal to some c into 2 power n, which is nothing but 2 into 2 power n is less than or equal to some c into 2 power n. What is the meaning of this one? Right will be greater or equal. You can take c value 2. Yes, it's true. Right will be greater or equal also okay. If you want, you can take 3 also. If you want, you can take 20 also. There exists a c, constant c, which is the 2, so that right will be greater or equal. Option A is true. Option A is true. So option A for big O, true or not? Yes. Can you say option A for omega? What is the answer? If you want to make omega, left will be greater, then c value 1. Omega also possible. If you want to make omega, left will be greater. Left is already greater. C value make 1 omega, because the big O omega both possible, then theta. Big O omega both possible, then theta. And one more, theta possible means there is no chance of small o. There is no chance of small omega. This is the way of finding small o, small omega possible or not. If anyone asks you between these two people, small o, small omega possible or not, please verify. What will you do? Theta is possible or not, verify. If theta possible, there is no chance of small o. There is no chance of small omega. Theta not possible, there may be a small o, there may be a small omega. Some people are asking me, theta not possible when small o. I will explain. Big O possible, what is the meaning? Less than or equal to possible. But theta not possible, what is the meaning? Equal not there. This is the way of finding small o is there or not. Big O possible means less than or equal to there, but theta not there means equal not there. Since the less than or equal to, remove the equal, which is going to be small o. Between two people, when can I say small o possible? Big O possible, but theta not possible. That means small o possible. When can I say small omega possible? Omega possible, but theta not possible. Omega means greater than or equal to, theta means equal, equal not possible means greater than. Right, like that. Now can you help in option A? Big O possible, omega also possible, so theta possible. Theta means there is no chance of small o, there is no chance of small omega. Right, fine. Option A is true because he is asking only big O. True. Now see the option B now. See the option B. Option B is a nice problem. Please listen this. Option B. See the option B. 2 power 2n is less than or equal to some c into 2 power n, which is nothing but 2 power n plus n is less than or equal to c into 2 power n, which is nothing but 2 power n into 2 power n less than or equal to some c into 2 power n. What is the meaning? I think you have to make right as greater. If you want to make right as greater or equal, c should be 2 power n. If you want to make right will be greater or equal, c should be 2 power n or more than that. But 2 power n is a function, so it is not possible. You want to make right will be greater or equal. So left is 2 power n into 2 power n. Right is c into 2 power n. So to compensate, c should be 2 power n. But 2 power n is a function. But c saying that I can allow only constant. That there is an option B is false. Option B is false. Please be careful. In the option B, if you observe, left is strictly greater. With the help of constant, you cannot make right side is greater. It is not possible. Small difference with the help of constant, you can make whichever side you want greater. But the problem is, right, function difference is there. Can you help me not? Right? Left and right in the option B. Right? Right is going to be function times smaller. So you have to multiply by function 2 power n. Then only possible. But C is going to be constant only. Function not allowed. Can you help in option B? Big O? No. Option B, big O, no. Next one, omega, yes. Some people are asking option B, how omega? Already left greater. So there is no requirement of C also. C value 1 you can take. Omega possible. See this one? Omega possible, big O not there. Means what is the meaning? Theta not there. Theta not there means equal not there. It is, do you believe or not? Option B is going to be, what is the small omega? Big O no chance. See this one, big O no chance. Whenever big O no chance, where is the concept of small o? No way. See this one, small o possible, big O possible. Right? Big O possible. So this one, big O is fail. Whenever big O fail, where is the chance of big O is fail? Where is the chance of small o? If big O pass, small o may pass, may fail. Right? Interesting thing is, if big O itself fails, small o no chance at all. Because big O is a superset, small o is a subset. Big O possible, small o may be possible. Big O no chance, small o no chance. Please be careful. Every time, in every problem, something new I am saying. Please you take care. I am repeating once again now. Big O possible, big O is a superset. What is the meaning of O is superset? Less than or equal, two choices. Less than also big O possible, equal also big O possible. Big O possible, small o may pass. Why? Big O contain less than or equal, small o is only less than. That is the reason. If big O pass means small o may pass. If big O fail, small o no chance at all. Right? Let's come here now. Option B, big O fail. Big O fail means small o also fail. That's okay. Next one, big omega pass. Big omega pass. But the thing is, right? But the thing is theta fail. Theta fail means equal fail. It is actually small omega. Small omega. Option B is actually small omega. But anyhow, big O fail. I am repeating now. For the option B, big O fail. I am writing now. Option B. Option B story let me write. Option B story. Big O fail. Small o also fail. Next one. Omega fail. Sorry, omega pass. Right? Small omega. What is the answer? Omega pass, small omega also pass. Next one. Because of it is fail. Theta no chance. Right? This answer. So option B is saying big O. That is the reason fail. This is the proof for that. This is the proof. And one more interesting answer. See, one more interesting answer. See this one. Everywhere I done mathematics only. See this one. Nowhere I applied shortcut. Everywhere mathematics. Everyone know. 2n means n plus n. 2 power n plus n means 2 power n into 2 power n. Pure mathematics I applied. Some people what they are doing is, they are applying shortcut. See the problem with the shortcut. 2 power 2n is one side, 2 power n is other side. Some people are applying shortcut. What is the shortcut? Apply log both the side. Apply log here. It is a 2n. This is n. It is looking like both as equal. See, both are looking like asymptotically equal. See this one. Between these two people, if you observe, right? I think this person is left hand side person is strictly greater, you know. After applying log, there may be a chance that both are asymptotically equal. I am really saying to you, in GATE examination especially, in competitive exam especially, right? When you are comparing both the functions, which is smaller, which is bigger, try to avoid applying log. Try to avoid applying log. If complex functions, right, really difficult things you can apply, right, you can apply the log, right? Small thing, if they are looking like very small, don't apply the, right, log both the side and all. Worst case you can apply. See, sometimes there may be around, see this one, right, one side is going to be 2 power, right, one side is going to be 2 power 2n, another side is going to be 2 power n, you know very well, this is bigger, but after applying log, asymptotically both as equal. That is the reason, don't apply log. Try to avoid applying log. This is the better to say. 90% you can apply, right? Remaining 10% especially in competitive exam, no need to apply, because sometimes it may lead to wrong answers. Best thing is, please try to apply your mathematical skills like this. Like this you apply. Suppose like this there is no clue, assume. Worst case you can apply log, right? But sometimes maybe small mistake will happen like this. Please see, now both are looking like equal. Actually the 2 power 2n is greater than 2n, 2 power n, but after applying log both are looking like equal because of asymptotically. See this one. Asymptotic means forget about constant. Mathematically they are not, see, mathematically previously not equal, now also not equal, but asymptotically if you see, asymptotically previously not equal, but now equal. After applying log there may be a chance of equal. So final conclusion from this problem, especially from second point, I want to say to you, please try to avoid using log, especially in exam. That is the only purpose of saying second statement, right? Please take care. You everyone know this kind of mathematics. Everyone, I am not done wonder here. Whatever basic mathematics I know, just I applied, right? Please take care. Let's go to the option C. So option B is false. Option A, who is true? Big O, okay. Next one, omega, okay, theta, okay. And one more, theta pass means no chance of small o. No chance of small omega. Please be careful. Theta means equal. How less than possible, how greater than possible. Less than or equal to possible because equal there. Greater than or equal to possible because of equal there. Because of equal theta. But when you say equal possible, how small o, how small omega. Right? Please be careful. Option B, you know, option B. This is the option B story. Big O, small o, theta fail. Small omega and big omega pass. Let's go to the option E. Option C. Option C, if you see, if A less than B, then n power A is big O of n power B, right? Where A greater than or equal to 1, B greater than or equal to 1, right? You take A value, B value, anything, right? You take anything. But they should be greater than or equal to 1. Please be careful, it's something like n square is, right? Big O of n cube. Next one, n power 25 is big O of n power 26. Right, like I think option C, nothing to explain also, it is true. And one more, can you help me now? Option C, big O possible or not? Yes. Next one, big O possible, it's okay, omega, no chance. So theta, no chance. Let me write now, big O possible. Right, omega, no chance. So theta, no chance. And one more, theta fail, but big O pass means, what meaning? Less than or equal to pass, but equal fail, means less than, small o pass. Small omega, no chance. This answer. Option C, whatever he is saying, true. Right? Let's go for the option D. Let's go for the option D. Please try to use the mathematical skills. See option D. Option D. Let me check this one. 4 power n by 2 power n less than or equal to some C into 2 power n. Which can be written as, you can do whatever way you want. Which can be written as 4 by 2 whole power n, which can be written as 2 power n less than or equal to some C into 2 power n. C value you can take 1. Yes, possible. Right? I think for the option D if you observe, big O possible because left also 2 power n, right also 2 power n. Big O possible. omega possible, theta possible, right? Because of theta equal, small o no chance, small omega no chance, right? So D is right. Can you help finally to this problem? Which are correct statement? What is asking? Find true statement for this problem. What is the answer? A true. Next one, I think B false. What about C? C true. What about D? D also true. Only B false. The purpose of this problem is B only. I want to say B. So B, those people who done like this. Second option, those people who done like this one, they done right. But those people who done the shortcut, right, they done wrong. So please be careful. Please be careful. There are two people mathematically not equal. After applying log, right, asymptotically may be equal. Please be careful. It will trouble you sometime. Best idea. In exam, try to avoid applying log. In this problem, A right, B false, C right, D also right. Right? Take care. Right? Next problem. See the next problem also. Right? So it is the next problem. Read it. Next problem, please read this. Find which of the following functions are polynomially bounded. Means out of these four people who are polynomially bounded, you have to find out. Out of these four people who are polynomially bounded, we have to identify. We'll say now, right? There is one small definition is there. Let me write the definition. See the definition. F of n is a function. F of n function is polynomially bounded. F of n is polynomially bounded. When can I say if and only if? F of n is polynomially bounded if and only if. When can I say? Is very simple. This one. Apply log of f of n. Apply log function. Log of f of n is, right? Log of f of n is big O of log n. Just apply. I can say f of n is polynomially bounded, right? After applying log for the f of n, this value not going more than log n. Means upper bound to this particular log f of n should be, to that one upper bound is going to be big O of log n. Please be careful. The meaning of this one is going to be f of n is polynomially bounded if and only if log f of n is big O of log n. What is the meaning? Log f of n cannot go more than log n value. Right? More than log n value it cannot go. Right? Now I am not saying that f of n cannot be more than log n. I am not saying log of f of n cannot be more than log n. I am repeating. Now last question I want to ask you. When can I say function A is polynomially bounded? When can I say function A is polynomially bounded? What is the answer? I am not saying that A value cannot go more than log n. Log A value cannot go more than log n. Then I can say A is polynomially bounded. That is the meaning. See this one? F of n is polynomially bounded if and only if log fn is big O of log n. I am not saying fn is big O of log n. I am saying log fn is big O of log n. Please be careful. If any fn which is behaving like this, that is going to be polynomially bounded. Right? So to get the clarity about this particular property, I given few examples. Please see this. Find which one of the following functions are polynomially bounded. I am trying now. See the option A. See option A now. N factorial is polynomially bounded or not, I want to check. So what you have to do? Apply log n factorial. Right? Check. What is the log n factorial? Which will goes to, what is the n factorial upper bound? N power n. Which will goes to, right? N log n. You know this very well. Log n factorial value is n log n. Please give the answer to me. N log n is big O of log n. Is it right or wrong? N log n is big O of log n. Is it right or wrong? Wrong, because it is n log n. It is only log n. Right? It is not. Because of that reason, right? This is not polynomially bounded. Polynomially bounded f of n means log fn is big O of log n. Then I can say polynomially bounded. Right? Fine. And one more. Another way of saying, a function is said to be polynomially bounded if its value cannot go more than n. If its value cannot cross more than polynomial. I'm repeating once again. A function is said to be a polynomially bounded if its value not going more than polynomial. This is one way of saying. If you want to eliminate the confusion, because the polynomial values are many are there. N is polynomial, n square polynomial, n cube polynomial. To eliminate this confusion, one more better idea is going to be a function fn is said to be polynomially bounded if and only if log fn is big O of log n. Just follow that. Anyone is okay, but this is better. This is better. Right? Fine. Let me ask you, what is the meaning of I am polynomially bounded? What is the meaning? My value cannot go more than polynomial. Next one more thing I want to say to you. What is the meaning of I am bounded to my family? What is the meaning? I may not cross, right, my parents' lives. Whatever my parents will say, right, maximum I will do those only. Maximum I will do those only. I don't cross their words. My mama papa words I may not cross. Then I can say that I am bounded to my parents. Suppose that whatever my brother and sister is saying, those only I am doing, right? Then I can say that I am bounded to my brother and sister also. So finally I want to say to you, function fn is polynomially bounded, means function fn value at any cost cannot go more than polynomial. So practical way of checking like this. Fn is polynomially bounded if and only if log fn is big O of log n, right? If anything satisfying this criteria, it is going to be polynomially bounded. I think n factorial polynomially bounded or not, I verified. Apply log. It will become log n factorial, which is nothing but n log n. Log n factorial, which is nothing but n log n. Right, fine. I think that now you are okay. Let's go to the B. Option A is fine. Option B. Let me check the option B. See this one. Log n factorial. Log n factorial, which is nothing but, everyone know, log n factorial. What is the upper bound for this one? Whenever you cannot write exactly, at least write upper bound. Log n factorial. What is the upper bound? Right? Upper bound of this one is going to be, what is the answer? Log n whole power log n. N factorial upper bound is going to be, what is the meaning of upper bound? Nearest, closest one who is more than that. N factorial closest one is going to be n power n. So same way, log n factorial, closest upper bound, log n whole power log n. Now what will you do is apply log both the side. Apply log both, right? Apply log. I applied. So what is the answer? This is f of n, which is equal to this. I applied log. This will become, what is the answer? This will become log n into log n. Right? After applying log, this is the answer. Is big O of log n. Is big O of log n. Right or wrong? No. Because log n cancel. This is the, I think, right, what is the answer? This person is smaller. This person is bigger. Log n time left hand side person is bigger. So this is fail. Just apply log. After applying log, this is the answer. Right? So answer is going to be, right, polynomially bounded is fail. Polynomially bounded is failed. Right? Fine. Let's go to the next one. What about this? This one also let me check. Log of log n. This is the given expression. To this expression, what is the closest upper bound? N factorial closest upper bound is n power n. Right? Next one. Log n factorial closest upper bound is log n power log n. Same way here. What is the closest upper bound? Let me write. Log of log n whole power log of log n. The closest upper bound. Now to this one, right? This one and this one, right? To this one, closest upper bound. Whenever expression is given, if you cannot do anything with the expression, what will you do? One expression is given, you are unable to do anything. Just write closest upper bound. Yes, I written. N factorial upper bound is n power n. Closest upper bound I written. Now apply log for this. If you apply log, what is the answer? Log of log n into log of log n. After applying log, this is the answer. Log of log n into log of log n. Right? Can you help me? It is big O of log n. Is big O of log n. Right? Is it right or wrong? See this one? It is a log n. Right? It is a log n. This is log n. This is a log n. This is a log of log n. It is a log n. No doubt at all. This is bigger. It is a log n, it is going to be log n, right? Log n is bigger. I think option C is polynomially bounded. Log n factorial, upper bound, log n whole power, log n. Right, next one. To this one, if I apply log, because I want log of fn, then it is going to be log n into log of log n. This is going to be log n. Log n is bigger, so polynomially bounded. Next one, let's go to the option D also. Still, if anyone having doubt, option D may solve your problem. See this one? Log n factorial. This is the given one. This is the given one. Which is nothing but what is the answer? N log n. Which is nothing but n log n everyone now. To that, let me find out log. Which will goes to log n plus log n is big O of log n. Is it right or wrong? Of course, right. So, option D also polynomially bounded. Can you help in this problem? Who are polynomially bounded? C and D. What is the meaning of fn is polynomially bounded? Right? Log fn value cannot go more than log n. Right? I think A is having that kind of problem. Crossing is happened. B also crossing happened. C and D crossing not happened. So, C and D is polynomially bounded. C and D is polynomially bound. And one more. Whenever any expression is given, if you are unable to compare directly, at least take closest upper bound. With that you can compare. At least. Right? Fine. So, I think to this problem answer is C and D is polynomially bounded, but A and B not. Right? Fine. Let's go to the one more problem. See this also. Example 9. See this one also. Find true statement from the following. 4 functions are given. From this you have to find out true statement. Right? We'll do now. Read all the statements. Find true statement from the following. Option A, f of n is big O of f of n by 2. Option B, f of n is big O of f of n whole square. Option C, if f of n is big O of g of n, then 2 power f of n is big O of 2 power g of n. D, 1000 n log n is big O of n log n by 1000. 4 options are given. They are really nice, right? Let's see this. One by one I will explain. Please try to get as much as possible. See the option A. See the option A, interesting one. See the option A. F of n is equal to big O of f of n by 2. Right? See what is the option A. See the interesting answer. See the interesting answer. This line is right or wrong? Let me check. This line is right or wrong. See this one? 2 power 2n is big O of 2 power n. Is it right or wrong? In the previous problem we done. 2 power 2n is big O of 2 power n. Is it right or wrong? It is a wrong. What is the reason? 2 power n is going to be 2 power n into 2 power n is less than or equal to some c into 2 power n. C cannot do. You know very well this cannot be. This is wrong. This is wrong everyone now. I am repeating once again now. To explain the option A. To explain the option A. I am explaining this. 2 power 2n is big O of 2 power n is wrong. What is the reason? This is nothing but 2 power n plus n. This is nothing but 2 power n into 2 power n. It is a c into 2 power n. It is not possible. If you really okay with this statement, now I am giving answer for option A. See this one? Option A. See the option A now. Assume that f of n is equal to, for option A I am explaining, f of n is equal to, assume that 2 power 2n. Assume. F of n is equal to, assume that 2 power 2n. Then what is the option A saying? F of n is see the option A. If f of n is assumed that this one, then option A is saying that, right, this one, 2 power 2n. Big O means less than or equal to some c into 2 power 2 n place n by 2. F of n is big O of f of n by 2. This side is f of n, same. This side is f of n by 2. See this one. N place, keep n by 2. You done the same. Here n is there. F of n is 2 power 2n. In the n place, keep n by 2. I kept, which is going to be 2 power 2n. Less than or equal to some c into 2 power n. Right? Where c is nothing but 2 power n required. Right? Fail. I'm really saying to you to explain the option A. Right? This statement required. Yes, this is fail. If you think that this is fail, same thing I done. Just replace f of n by 2 power 2n. So f of n is 2 power 2n, some c into 2 power 2, n place n by 2 you keep. This will become like this. So fail. So option A need not be true. Sometimes may be true, right? One case fail, fail only. So option A fail. Many people are thinking that option A pass. Many people thinking that option A pass, option A fail sometime, right? Like this. Some people are asking like this means what? Right? This is fail means, right? Same thing I kept. Assume that f of n is, assume, I am writing here. Assume f of n is 2 power 2n, then 2 power 2n is left side less than or equal to some c into 2 power 2n plus n by 2, which is nothing but this fail. That is the reason fail. One fail, fail only. Some people are asking, sir, how can you assume f of n is equal to 2 power 2n? Through practice I got. When you do more problem, you will get to know. Right? When you do more problem, automatically you will get to know. Don't worry at all. Right? Sir, how you know that f of n is equal to 2 power 2n? How you know that? Right? It is very difficult to say now itself. Right? When you practice many problems, you will get the clarity. Do meaningfully. Automatically your brain will suggest to you, please go through it. If you do more practice, right, brain will work more fastly. If you do less practice, it will go slowly. Everyone will give answer. Some people will go slowly, some people will go fastly, depending upon how much practice they will do. Right? Option A false, that is the reason. And one more. See the option B. Interesting answer. See the option B. See the option B now. Option B saying that f of n is big O of f of n whole square. Let's see this one. Is it right or wrong? Isn't that f of n is n? Then what answer? Left n. Right is going to be big O of n square. F of n is assume that f of n is n. I think this is right. But see the problem. Many cases may be right like that, but one case fail only. See this one? One case fail. Assume that f of n is equal to 1 by n. Assume. So left is going to be 1 by n. Is big O of what answer? 1 by n whole square. Everyone know 1 by n. If the n value is 2, right? 1 by 2 here, but it is 1 by 4. We assume that n value 10, 1 by 10 here, it is going to be 1 by 100. So definitely, right, this side cannot be bigger, this side only bigger. So that is the reason, this is fail. 1 by n is big O of 1 by n whole square, right? I think it is need not be. Right? That is the reason. One case fail. See, many cases may be pass like this. One case fail only. So option B fail because of that reason. Can you help Option B is true when? Option B is true when f of n is big O of f of n whole square. When? If f of n is an increasing function, then it is true. What is the meaning of increasing? N value increases, value will increase. Right? Then it is going to be increasing function. N increases, value increases, that is called as increasing function. N increases, value will decrease, that is called decreasing function. Option B is false for decreasing functions. Right? See this one. N value 1, 1 by 1. N value 2, 0.5. N value 3, 0.33. N value 4, 0.25. N increases, value decreases. This is called decreasing function. These are called increasing function. Option B true for increasing function. B false for decreasing function. Some people are asking me, then how can you take decreasing function and all? Try to remember, starting of the asymptotic notation I explained to you very clearly. I am explaining only for positive functions, not negative. Right? Positive functions only. Those positive functions may be increasing, may be decreasing. Right? Positive functions only we are discussing. Right? Positive functions, you take anything, no objection at all. You may, depending upon function, sometimes function may increase, sometimes function may decrease. Right? Depending upon what is going on and all. But one thing, only positive functions we are discussing, those may be increasing, those may be decreasing. Option B true for increasing function. Right? Option B is going to be false for decreasing function. It is the decreasing, right? This is false. So that is the reason B is false. Right? Please be careful. Now see the option C. See the option C is the interesting one. Please see the option C. See the option C now. Option C saying that if you want you can read. Option C saying that if f of n is big O of g of n, then 2 power f of n is big O of 2 power g of n. Means what the meaning? Between two people big O possible, after keeping in the power also big O possible between them. Right? Let's see this one. Interesting answer. Let's see this one. Can you help now? F of n is assume that 2n. G of n assume that n. f of n is assumed that 2n, g of n is assumed that n. Now can you help me now? Is it right or wrong? Let me check. Is it right or wrong? Let me check. See this one? F of n is big O of g of n. Is it right or wrong? That means what is f of n? 2n. 2n less than or equal to some c into g of n. Right? C value 2 you can take. So big O possible. If f of n is 2n, g of n is n, f of n is big O of g of n is possible because f of n 2n less than or equal to some c into n. C value 2 you can take. So between f of n and g of n, big O possible. Everyone know. Now some people are asking, between these two people, big O possible. Now if you keep in the powers, let me keep in the powers, if you keep in the powers 2 power f of n is less than or equal to some c into 2 power g of n. Is it true or not? Let me check. Is it true or not? So 2 power f of n is 2n less than or equal to some c into g of n is n. C value now required 2 power n, which is not possible. So what I want to say, between two people, if at all big O possible, after keeping in the powers, big O may not be possible. See, I kept in the powers. Right? I kept in the powers, please see. 2 power f of n less than or equal to c into 2 power g of. Before keeping in the power, it is working. See. After keeping in the power, it is not working. What is the reason? Before going to keep in the power, c value only 2 required. But after keeping in the power, c value 2 power n required. That is the reason fail. I am repeating once again. Between two people, big O possible. After keeping in the power, big O may not be possible. Right? That's what the option C is saying. Right? So let's see this one, option C. Option C, big O fail. If you want, you can check omega also will fail. Right? Theta also fail. Please verify. These three will fail. Big O fail means theta also fail. Between two people, big O possible. Right? After keeping in the power, big O need not be pass. May pass, may fail. Omega also say, right? Let me read. Sorry for this one. Big O fail, omega fail, theta fail. These three will fail. Example also I given, please check. F of n is this, g of n. Big O possible, but after keeping in the power, right? Big O not possible. Same thing with omega also, same thing with theta also. Let's go to the option D. Let's go to the option D. Can you help me now? What is the left side? N log n. What is the right side? N log n. Forget about constant. Left side, right side, same there. Constant don't bother because there is a C who will take care. Left side n log n, right side n log n. Big O possible, omega possible, theta possible. So here, big O possible, omega possible, theta possible. When you say theta, no chance of small o, no chance of small omega. These three will be possible. Because left and right, don't see the constant, see the only function. Constant C will take care. If anyone having small doubt also, see this. 1000 n log n less than or equal to some C into n log n by 1000. It is 1000 times n log n. It is going to be n log n by 1000. Right? But I want to make right as bigger. So what is the answer? Nothing there. So you want 1000 n log n this side. So let's keep this. Right? C value make, right, approximately how much? 10 lakh. So can you help me now? 10 lakh into n log n by 1000. I think 30 cancel, 1000 there. So right will be either greater or equal. That's fine. So big O possible for C value this. Right? Omega possible, C value 1 because already left greater. So theta also possible. Nothing there. Forget about constant. Left side, right side, bigger functions are same. So big O possible, omega possible, theta possible. So D is a right statement. Can you help me now to this problem? A false, B false, C also false, D pass. Can you say what is saying? Find true statement. I think only D is the true statement. It is a nice problem. Many things you can learn. Please you take care. Ninth problem, only D true, remaining all are false. Right? Let's go to the one more problem. See the next problem? Right? Read this problem. F of n is nq if value is less than 1000. N power 4 if value is from 1000 to afterwards, 1000 onwards. Again I am repeating now. F of n having two possibilities. What is the one possibility? Nq before 1000 From 1000 onwards n power 4. G of n also having two behavior. Until 99 or until less than 100 n square. From the 100 onwards n power 9. F of n having two behavior, G of n also having two behavior. Can you say what is the f of n behavior before 1000 n cube? From 1000 onwards n power 4. G of n behavior, right, before 1000 n square. From before 100 n square. From the 100 onwards n power 9. So both are having two different behavior, right? Now can you help me one small and how to solve this problem? You only say. How will you solve this problem? F of n having two behavior, G of n having two behavior. Right? How will you solve this? What is the conclusion? What is the conclusion I will say? Can you say what is the meaning of n0? In all the asymptotic notation, what is the meaning of n0? From that point onwards. Right? N0 means what? From that point onwards. I am able to see clearly what is the relation going on between them. Right? From n0 onwards, I am able to see clearly what is the relation going on between them from n0 to until infinite. Until infinite. There is no ending boundary. Starting boundary is n0. From n0 onwards, I am able to see clearly what is going on between them. Right? Starting is n0, ending is no boundary. What is the meaning? Until infinite. Can you help me now? F of n is n cube until which point? F of n is n cube until which point? Until 999. Until 999. But I don't want until 999. I want from which place? This is after 0. What is the meaning? From 1 onwards until 999 n cube. This is from 1000 onward. 1000 onwards n power 4. F of n is 1000 onwards n power 4 until infinite. Next one, G of n is right from the 1 until 99 n square. From the 100 onwards is 100 onwards n power 9 is 1000 onwards n power 4. Can you help me now? 1000 onwards is n power 4. Right? 100 onwards is going to be n power 9. Now can you help me one small line now? 1000 onwards n power 4. 100 onwards n power 9. See this one? 100 onwards n power 9 means what about 200? Same. What about 500? Same. What about 1000? Same. 1000 onwards n power 4. 100 onwards n power 9. Can you help me one small line now? F of n is how much? N power 4. G of n is how much? N power 9. Can you say who is bigger? G of n. See this one? F of n is big O of G of n. F of n is big O of G of n. Comparing F of n and G of n, G of n is bigger. From which place is n power 4? 1000. From which place is 100 onwards? 1000. Can you help me now? What is the common point? What is the common point from where this relation hold good? What is the answer? 1000 onwards. 1000 onwards this relation hold good. 1000 onwards is n power 4. 1000 onwards is n power 9. So bigger one is n power 9. Some people are asking, sir, is from 100. 100 onwards means 1000 also there. But 1000 onward doesn't mean that 100 there. Right? 1000 onward means more. 100 onwards means more than this. So 100 onwards, 1000 I can write. So from 1000 onwards, if you see both the people, G of n is greater than F of n. We don't bother, see this one, we don't bother. In this area, how much behaving? In this area, how much behaving? Try to remember, asymptotic notation don't have ending boundary. It is having only starting boundary, m0 only there. Can you help me? F of n is big O of G of n. For all n, where n is greater than or equal to n0. What is the meaning of n0? From n0 onwards until infinite, G of n is greater comparing with F of n after taking CL. That is a big O. Same thing here. F of n is big O of G of n because F of n is n power 4, G of n is n power 9. So from the 1000 onwards, right, see this one. E is going to be n power 4. From which place onwards? n0 is going to be 1000. Can you help me? E is going to be n power 9. From which place onwards? 100. What is the common point? Common point is going to be 1000. 1000 onwards. Comparing F and G, G bigger. Comparing F and G, G is bigger, 1000 onwards. Right? See this one. Some people are asking me, what about the n cube? What about n square? See this one. Asymptotic notation don't have ending boundary. It is ending boundary there. Don't take. This is also ending boundary there. Don't take. Only starting boundary. 1000 onward this. 100 onward this. Common point is 1000. 1000 onwards comparing F and G bigger. Right? Whenever many relations are given for F, for G also, right? Take that point where don't have boundaries. Starting boundary should be there according to asymptotic notation. Ending boundary cannot be there. From this point onwards until infinite, F and G bigger. That is called big O. From the N0 onwards, F and G bigger. Right? That is called as big until infinite. By default, infinite will be there. Ending boundary by default. Here ending boundary 1000. That is right. Ending boundary 999. That is I am not taken. Here ending boundary is 99. I am not taken. No boundary. From here onward, this is. From here onward, this is. So from the 1000 onward, this is the relation between them. So take only these two. These are not required. Only to confuse you, they are given this. Relation between F and G. What is the answer? Fn is big O of Gn. Can you say, is omega possible? No. So theta no chance. So what is the answer? It is actually small o. F of n is big O of G of n. So omega not possible. So theta not there. Theta not there means small o. Right? Answer for this particular problem is Fn is small o of Gn. Right? That is the answer for this problem. Let's go to the next problem. What is the previous problem? I think 10. Now 11. It is the 11th problem. Right? See the 11th problem. Fn is equal to n power 1 plus sin n. Gn is equal to n power 1 minus cos n. What is the relation between them? So I think some two trigonometric functions are given. They are asking what is the relation between them. Right? We will see now. Right? Let's make sure that everyone listen. So what is the answer of this? So I am explaining now. N value this side. N value this side. Right? F and Gn is this side. You can do whatever way you want, no objection at all. I will explain roughly, please see, please be careful. It is 0. N value this side, F and Gn is that side, that's okay. Now let me ask you one small line. What is the sin n graph? What is the sin n graph? Let's check sin n graph. It is a 0, it is a plus 1, it is a minus 1. Right? It is a 0, minus 1, plus 1. Right? It is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Just I am writing roughly sine graph. You know very well, only for namesake I am writing. Can you help me now? Sine 0, 0. Only for namesake I am writing. Can you help me now? Sine 0, 0. Can you say sine 90, 1. Sine 180, 0. Sine 270, minus 1. Sine 360, again 0. It is a sine graph. Sine 0 is 0, 90 is going to be 1, 180 is going to be 0, 270 is minus 1, 360 is going to be 0 again. It is a sine graph. You know cos graph also. Let me write cos graph also. Many people know. Only for namesake I am writing. Cos n graph. Right? In this color I am writing the cos n graph. Can you help me now? Cos 0, 1. Can you say cos 90? 0. Cos 180? Minus 1. Cos 270. Cos 270. What is the answer? 0. 360. Right? 1. Cos 0 itself 1. See, from which place you started, same place you have to go. Right? So, I think this color indicates cos n, this color indicates sin n. You know very well. Sine graph, cos graph, you know very well. Right? Only for namesake I done this. Right? If you are really okay. Right? Let's start here. Let's start. Right? Can you say this one? Fn Gn. Right? Fn Gn. Let me do the Fn now. Let me do Fn. Fn I am doing with the green color. Say this one. Fn. What is the Fn? N power 1 plus sin n. Fn is equal to, right? N power 1 plus sin n. Let's check here. Let's check. It is a 0. Plus 1. Plus 2. Same thing, if required, minus also will come. Minus 1. right? Fine. Next one, it is 0 degrees, 90, 180, 270, 360, right? Now I'm starting now. See, so now I'm starting. Can you help me one small line now? So, and one more thing, because the below part is same, no need to compare with the below. Above only compare. Below part is same, n power. That is the reason there is no problem. Above part only compare. Can you help me now? Let's start. Fn I am concentrating. Let's start now. Can you help me now? What is the sign 0? Fn, I am starting from here. Sign 0. Sign 0 is going to be 0. 0 plus 1, 1, right? I think at the 0, 1k. I am repeating once again now. Sin 0, 0. 1 plus 0, 1, right? So 1 is there. If it is the n is there, n. The other than this, nothing there. You don't worry that much. Next one. Sin 0, that is the story. Can you say sin 90? 1. 1 plus 1, 2. It will goes to 2. Next one. Can you help me now? What is sin 180? Sin 180. What is the answer? You know very well. If you have doubt, check. Sin 180. What is the answer? I think this color. Right? This color is going to be sin story. Right? So can you help me now? Sin 0 is 0, sin 90 here, sin 180 is 0. Right? Let's check here. Can you help me now? Sin 180 0. 0 plus 1, 1. Next one. What about sin 270? Minus 1. 1 minus 1, 0. Right? I think it will goes to 0. Next one. What about sin 360? 0. 0 plus 1, 1. From which place you started? Same place. This place you started journey, this place you went. Only powers I am comparing because base will be same. Base are same, then you no need to think that much about the base. Think about only powers. Right? I am thinking that it is the sign, right, f of n behavior. Let's go for g of n. Let's go for g of n. See the g of n, right? Start. Can you help me now? Cos 0, 1. 1 minus 1, 0. So, I think it will goes to 0 from here. Now you say this one. Cos 0, 1. 1 minus 1, 0. Right? From here he started. Next one. Can you say cos 90? Cos 90. What is the answer? Cos 90 is going to be 0. 1 minus 0, 1. It will goes to 1. Next one. Can you help me now? Right? What about cos 180? If you have doubt, you can see here. This is the cos. Can you help me now? Cos 180. What is the answer? Minus 1. Right? Let's check. Minus 1. 1 minus 1, 2. Right? It will goes to 2. 180 is 2. Next one. Can you help me now? Cos 270. Cos 270. Check here. Cos 270. What is the answer? 0. Cos 270 is 0. So it is 0. 1 minus 0, 1. It should come to 1. Can you help me now? Cos 360. What is the answer? 1. 1 minus 1, 0. So this is the right sin n, right, f of n, g of n graph. This is for f of n. Right? So f of n, g of n. Right? I hope everyone fine now. So please see this one. See this graph. Because of, I am repeating once again. You know very well sine graph. You know very well cos graph. Only for namesake I drawn. If anyone having small doubt also cos graph and sine graph. Right? Please see this. Cos graph, sine graph, if you have small doubt also, please see this one, I drawn this. Right? This is belongs to, right? This is belongs to, right? I think cos graph, this is belongs to sine graph. Now, if you are okay with that, I went here. While calculating this one, right? Base I didn't cover because same. Powers only I compared. Compare the powers. After comparing, see this one. This graph, right? This green color graph is going to be Fn. Right? Next one. This yellow color graph is going to be Gn. Right? Please be careful. By seeing this graph, please let me know. Can you help me now? At the initial stage of the graph, 0 to 90, who is bigger? Fn bigger. Next one. So at the 180, who is bigger? G bigger. G bigger. Can you help me at the 360 who is bigger? F bigger. I think by seeing this graph, please let me know, right? Sometimes F bigger, sometimes G bigger, right? So sometimes F bigger, sometimes G bigger. This is happening in 360 degrees. But you know, trigonometric function, right? For every 360 degrees, same story will behave. What is the answer? Sometimes, right? Initially F bigger. Afterwards G bigger, afterwards F bigger. This is the 360 degrees behavior. For every 360 degrees, trigonometric function will behave almost similar behavior. So, I am unable to say clearly F bigger or G bigger. Because sometimes F bigger, sometimes G bigger. I am unable to find out N0. From there onwards, I will see the clear relation between them. I am unable to see that. There is no N0 from where I can say F only bigger. From where I can say G only bigger. I am unable to find out. So because of that reason, can you help me one small line now? Some point onwards, I am unable to say F only bigger, G only bigger. I am unable to say that. So what can I say now? Fn, Gn. Fn and Gn are, right, asymptotically not comparable. Not comparable. You cannot say anything. Can you help me know what is the meaning of comparable? Asymptotically comparable. What is the meaning? Either big O possible, or omega possible, or theta possible, or small o possible, or small omega. I am unable to say anything. What is the reason? Sometimes F bigger, sometimes G bigger, right? We cannot say anything. From this point onwards, clearly F bigger, clearly G bigger, clearly both are equal. Then I can say some relation. Because of it is keep on oscillating. So we cannot say. So Fn, Gn are asymptotically not comparable. Yes, in previous all problems, right? Some comparisons are possible. We done that. Now not possible. Asymptotically not comparable. Right? Please be careful for this problem. Sine graph required, cos graph required. I explained. If you have small doubt, please go through it. Afterward, right? Fn also n power something, Gn also n power something, because of both the powers, both the bases are same. Powers I compared. Right? I drawn the graph. Directly I can say also, but I drawn the graph. I explained. You got to know that in 360 degrees itself, what is happening is starting F bigger, in the middle G bigger, at the end once again F bigger. This is happening from in every 360 degrees. We are unable to say F only bigger, G only bigger from some point onward. So not comparable. Right? Please be careful. This is the problem. Graph also, if you want, you can check. Here who is bigger? F bigger. Here who bigger? G bigger. Here who is bigger? F bigger. This is same thing happened further also. So I am unable to comment. It is a sin n graph and cos n graph. Right? Fine. I am really thinking that you are comfortable. Let's go to the next problem. See this also. If anyone having small doubt also, let me explain this. Let me explain this problem also. See this. One more problem for a trigonometric function. Fn is equal to n power sin n. Gn is equal to n power 2 plus cos n. What is the relation between these two functions is asking? I am checking now. I am checking. See this one. It is a 0. It is a minus 1. Plus 1. Plus 2. Plus 3. If required, we will take next one. It is going to be minus 2. Right, fine, it's okay. It is a 0, minus 1, minus 2, plus 1, plus 2, plus 3. That's okay. Next one. It is a 0 degrees, it is a 90 degrees, it is a 180 degrees, 270 degrees, 360 degrees. That is also okay. Right. Let's start now because our bases are same. Compare only powers. Sin n 2 plus cos n. Right? Sin n 2 plus cos n. Let's start now. What is the sin 0? 0. Next one, sin 90, 1. Sin 180, 0. Sin 270, minus 1. 360, 0. Like it is a sine wave. So it is the f of n. F of n is almost like sine wave only because we are comparing only powers. Now go to the next one now. G of n. Let's go to the G of n. Right? Can you help me now? Cos 0, 1, 2 plus 1, 3. So I think right, G will start from here. Cos 0, 1, 1 plus 2, 3. 3 onwards he will start. Can you help me now? Cos 90, 0, 2 plus 0, 2. right? I think 90 also. Okay, 180, cos 180. Cos 180, what is the answer? Minus 1. 2 minus 1, 1. Right? Next one, cos 270. Cos 270, what is the answer? 0. Cos 270 is going to be 0. Please verify yourself. Cos 270 is going to be 0. 2 plus 0, 2. Cos 360. Cos 360, 1. 2 plus 1, 3. See, from which place you started? Same place. I think everyone know below graph is going to be Fn. Above graph is going to be GN. C is nowhere matching. So I think always who bigger? G bigger. So answer is always G bigger. So answer is going to be Fn, Gn. Who is bigger? G bigger. So big O of G of N. And one more thing I want to ask you, right? I think is there any chance of theta? No, they are different. This is different. So what is the answer? I think omega is fail. Check yourself. Theta is fail. So answer is actually big O, which is actually small o. So to this problem, answer is going to be, right, big O. Big O, right? Small o means big O also. Actually small o, which means big O also. Big O doesn't mean that small o. F of n is big O of G of n, right? In these two options, right? If these two there, select the small o. Small o means big O also. You can select this also, no problem. If you want to select one, go for small o. Right? Fine. If both are there, if at all both options there, go to the both. Right? Fine. It's okay. To this problem, answer is going to be F of n is big O of G of n. Right? Small o also true. Actually small o.